I'm going to start by welcoming you all along. Thank you so much for coming along and joining us. My name's Rob. I'm part of the product team at PegaSys, and welcome to our very first onboarding webinar. As I say very first, there's a chance that everything might go horribly wrong and the world blow up. My apologies if that does. I do expect though that we put some effort into this and made sure that this can be a good experience for you all. And do though forgive us if there's some rough edges as we go. So the purpose of this webinar is really to help bring you on board with the Pantheon product. We know that it can often be hard to know how to start working on a product and start to know how it works. So we're just going to be sort of introducing the bit of the feel for Pantheon, give you a bit of a feel for how the product works. If we go back and have a look at some of the people that are involved in this webinar, Lucas will be sitting there as our protocol engineer, asking some of the hard questions that you might have. I think he's hoping that there aren't any too hard questions, but do feel free to bring whatever you've got. We've got Don, who's going to be driving us through the webinar. He's one of our content writers for our team. We've got Sally, who's also a protocol engineer. She's going to be there monitoring the chat. So if you do have questions at any time, please do drop them into the chat. Sally will take note and will be collating them. There's a few different sort of stages throughout this webinar where there'll be a great spot to sort of pause and ask questions. And so if you just drop them at any time through the chat, Sally will share them with everyone when it's the right time. That's the team that we've got presenting. We're going to just have a quick look at the Pantheon roadmap. And this is really to give you a bit of a feel for where we are as a product and what you're actually learning how to use. So we've just released the Pantheon 0.8 version, and I say just, it's actually getting to be a little while ago. So that was in October, and we just released last week the 0.8.3 version of it. And so each of those sort of minor versions that we've been releasing has been helping to improve the quality of the Pantheon release. And it's getting very, very close to this 1.0 version that we're going to be releasing in February. And so that 1.0 February release, it's going to include a much more solid client than our 0.8, which was already a good sort of quality bit of software. But it's going to be one that we've sort of had hardened from a few months of running out in the wild, running against the main Ethereum chain. And it's also going to start to include some more of our enterprise-related features. So the Pantheon 1.0 release in February is going to be our first 1.0 release of Pantheon. And it's going to be the release which is an enterprise-ready product as well, with some custom consortium network consensus mechanisms, and also the permissioning piece as well. In April, we're aiming to release the 1.1 version of Pantheon, which will include more advanced permissioning related features and also some privacy features as well. And then we've got this amazing roadmap of things that we're working towards with the Pantheon 2.0 and beyond. And it's I'm actually really excited about the product that we're going to be releasing in February, and then also the roadmap that we've got for that in the future as well. So more advanced things around privacy, making sure that we're fully compliant as an enterprise Ethereum Alliance client, adding things like more advanced consensus mechanisms, starting to look at some more integrations with the enterprise world. And then there's a bunch of really exciting research that will start to be pulled into our product as well. That's our sort of big thing with the Pantheon product, and that's what we'll be helping you to be able to work with today. We look now at just some friendly reminders as we move into the actual meat of this webinar. Really, this is being set up to be something that you can really follow along with. Or if you want to just watch, you can watch as well. We're happy either way. Another option which you might find really useful is to sort of watch it first, and then maybe when the recording does come out. So as Faisal mentioned in the chat, we're going to be recording this for perpetuity. So if you do want to sort of watch as we go through the first time and then maybe do it yourself later, that's a great way to go as well. Before though you do it yourself, you will need to do the prerequisites, which is essentially ensuring that you've got a Pantheon up and running on your local environment. And so those instructions have been emailed to everyone that's watching this call live. I assume that they will be linked to right next to wherever this webinar is. And if you can't find them, please do contact us at support@pegasus.tech, and we'll have someone happily send through some of those prerequisites to you. I can see that everyone's done a great job already at muting. If you can please continue to do that while someone else is talking, it helps just ensure that the voice of the person who's talking comes through really clearly. As I mentioned earlier, we'd love to have you asking questions in the chat as we go along. And Sally will definitely be watching out for those and making sure that we're answering those questions. And then I think there's about 4 sections in the webinar. So we will again pause after each of those sections for everyone to ask questions either at that time audibly, or Sally will then be speaking out the ones that have been asked in the chat. Also in the chat, there will be any code or commands that Don is typing. They will be pasted into the chat for you. So you can just copy and paste the commands out of the chat into your terminal or wherever is the appropriate spot at that point in time. We have a Q&A session at the end, and I think that's pretty much it for the friendly reminders. I hope that you enjoy the webinar, and we look forward to answering any questions that you might have either now or in the future. Back over to you, Don.
All right, thanks, Rob. So our tutorial, we're now looking at my screen, and I'm going to drive through the tutorial. And let me just first say that what the tutorial is, and we're going to be using the Pantheon client to run a private network of Pantheon nodes in a Docker container. And so it's going to run the private network right in the Docker container. And this is based on a tutorial that we have. It's called our private network quick start tutorial. You can find it in our docs. To begin, I am using a Windows computer. Of course, there's going to be differences between Mac and Windows. I will try to note all differences as I go along. And so everyone's computer environment is different. There may be little glitches. So if you do run into anything, feel free to put a question or issue in the chat. Again, our team will help you out. All right, so also I'm going to be taking very brief breaks after each section to give us a chance to catch up and make sure everyone's okay, look at questions or whatever. The first thing we want to do is start, for Windows users, running PowerShell. And let's go to wherever you installed the Pantheon Quick Start. If you cloned it or downloaded it, let's go there. And take a look at the contents. So what we have here is a number of shell scripts. Run is the first one going to run. It will build the container images and run the network. Then list will list the containers in the network. And you can use stop to stop the network but not destroy it. You can then call resume to resume it, since it's still there on the images are still there on your computer. And finally, there's remove, which will both shut down the network and remove all the containers. So you would want to do that at the end if you want to clean up your system. So let's start with run. And so on Windows, it's going to be ./, on Mac ./, and we're going to give it an option that specifies port number. The port number we want to use for the demo is 32777. Now, if I don't use this option, it's okay. The the script will assign a random port number, but we would have to do an operation to obtain that. So now what we're going to see here is Windows has spawned a child terminal, and it's spinning up the Docker containers. And this takes several seconds. It's really pretty quick. And when it's done with the process, it lists out what's there and then disappears, which is not really the best experience. So on Mac, you're going to have everything listed out in the main terminal, and it persists there, so you're good. On Windows, what we're going to need to do is just give it a Docker compose command to list out what container images are here. Docker compose PS. So what do we have here? We have all our nodes running. The state is up for all of them, which is what we want. They're all active. We have 4 peer nodes. So these nodes just talk to each other in the network. We have a miner node that mines Ether. We have a boot node, and the boot node is basically a gateway node that the other nodes can contact to discover who else is in the network. So it's basically a network gateway. And then we have an RPC node. So the RPC node's purpose is that later on when we make, we're going to make RPC requests on this network, and we will be pinging that node. Finally, there's an Explorer. This is not a node, it's an Nginx service, and that is going to support a browser-based graphical explorer that will let us have a better view on this network. All right, so since we've started it up, I'd like to take a quick break and see if there are any issues going on, questions.
The only thing that's popped up in the chat, Don, is just that Docker needs to be running as a service before you can actually start.
Yes. Good point. Yes. You want to make sure, click in your services tray, and if you see the whale, Docker's running. If it's not, make sure that it starts. And it does need to be running. So hopefully everyone's up to speed, and I'll move on. The next thing we're going to do is bring up that block explorer as I promised. Now I'm using Chrome, and I'm going to open a new tab. And while I love looking at Paul Clay, I think the browser is a little more interesting today. What we want to give it is a URL, and the URL is it's the same port number. It's on localhost, and it's the same port number that we specified, 32777. Very simple. Let's put it in the address bar, ping that, and so it's initializing right now. And in a few seconds, we're going to see information about the network in a graphical format. It says that it's running Pantheon client. We have 6 peers, and our best block, which is the currently latest mine block, highest mine block, is number 7. If I click that, I get detailed block information. This is really nice. So we've got the block index, the hash of the block, a unique identifier, the hash of the parent, the nonce, the block size, and if there were any transactions stored in that block, they'll be reflected here. And there would also be, right, so there would be transactions would be listed here. On the left, this is a 20 block window of the blockchain that's currently being mined, and every so often you'll see it update. In fact, if I click the parent hash right there, we can go back in the chain and keep going back, and I can click any of them. So one thing I can do is I can copy, for example, I'm going to copy the hash of the this parent, the parent of block 9. Go back to the front page, paste it in there, search for it, and it's block 8. So it's just a nice viewer. Another thing that I want to point out here is you're going to see how fast this will update every few seconds, and will show us that it's going to increment a couple of blocks every, say, 10 seconds. The network mines every roughly 5 seconds. It's a very small network, so it's mining quickly. Actually, it's a little slow today. 6 peers. This is, hang on a second. When I explain why it says 6 peers, hang on a sec. So we're pinging the RPC node, and it's counting the 4 peer nodes, the miner node and the boot node. That's 6. It does not count itself. So 6 is the correct number. All right. Are there any questions at this point?
There are a couple of questions. There's a question about the brew installation of Pantheon. I know we hadn't planned to cover that in this webinar, so we might take that one offline, unless someone wants to jump in and answer it now. I'm looking at you,
Lucas.
Yeah, we definitely can go through it. I think the question was about using Brew to run a private network. The short answer is yes, you can use it. It's just going to be a little bit more work to set up all the nodes and make sure that they talk to each other. So, but yeah, I'll find the links from the docs on how to set up a private network, and I'll send it on the chat.
Thanks, Lucas. Another question is, what is the consensus mechanism used? Are we using click? So I know the answer to this one. We're not using click yet, but we're working on it. So the consensus mechanism that's in there right now is proof of work, right?
Yep, you're using eth hash proof of work with a really low difficulty. That's why we mine blocks that fast.
Yes. Very low difficulty. All right. All right, so moving on, what else can we do? So this graphical view is very nice, and the way that this, by the way, this block explorer is made by Alethio, another spoke in Consensus, and they were kind enough to build this for us, and it uses RPC requests on the back end to ping the network and get all this information. So we can do the same thing programmatically using Postman, and Pantheon has a JSON RPC API, which is a number of methods. So let's fire up Postman. And what you want to do is, when it comes up, go to your directory wherever you installed Pantheon, click Start, and look in the docs folder. Inside the docs folder, there's going to be a collection file. So this is, Postman collection is basically a JSON file that is a bunch of pre-saved, it's a collection of pre-saved methods. So we don't have to, type them in as we go. We can just load this in. So how do we do that? If you started Postman, click Import, choose Files, and you'll want it to go to that directory, Pantheon Quick Start Docs, on your machine. Select that file and open it, and it shows up here in the left nav. And we have 5 methods preloaded in here. So let's look at the first one. Net peer count gets the number of peers in the network. And this is, we're going to want to correlate this to this number that we see here in the Explorer. Before I call it, I just want to point out that in our JSON RPC API, everything, all the methods are called as post requests, and where the endpoint that we're hitting is basically the numerical version of localhost and then the port number that we specified, and we append JSON RPC to specify that it's that service. If you click the body tab, you'll see the method body, and this one is not terribly interesting. Just says this is the method requested and no parameters. So let's send it. And we're going to get JSON data back, and our data is typically in hex. What is this? 6, and that's, of course, that's the number we wanted, 6 peers, which is nice. Another method we can call is block number. And we look at the body here. Also, no parameters, very simple. It's just going to get the best block, this number here. So before I call it, in preparation, now we know we're going to get a hex number. So you can open a tab and go to binaryhexconverter.com. And when you go there, make sure you select hex to decimal. We'll be ready to convert our result into a decimal number. Okay, let's call this. So let's see, here's the game. We look at our browser, we're on 95, quick like bunny. We call it, copy 62 hex, convert, and it's 98. It says 98. 92, we were way behind. I was way behind on that one. I'll try one more time. 67. 103. Oops. 103, 107. So that works pretty fast. It's always going to be a little bit ahead of us. But we are basically, when we call these methods, we're getting a snapshot. So that's just a very simple demo of our RPC, our JSON RPC API. I'm going to take a quick break. Are there any questions at this point?
Yeah, there's a couple of people getting a host not authorized error from running those commands in Postman.
So,
okay, so using localhost
I was gonna suggest maybe in Mac, part of the list will be we'll give you this this URL. And I'm not sure. I know that on Windows I have to append JSON RPC. I don't know if that's true on Mac. You might want to take that off. But I thought that was it. The other thing is double check on the port number. And in Windows, you can do that by running Docker compose port explorer 80. That should return. That'll verify the port number. Those are a couple things that come to mind. But again, it's 127.0.0.1 and then the port number.
Yeah.
Yeah, I believe one of the reasons is due to the security mechanisms that we have to avoid. Recently, we introduced a DNS rebinding security feature that it will force you to specify the host that it can actually access the system. But I believe that for this development setup, localhost is going to be whitelisted. So if you're having problems, try using localhost instead of the 127.0.0.1 IP, and hopefully it's going to work. If it doesn't, just give me a wave and we can try to get it sorted.
Okay, it looks like most people have that sorted out in the chat. There was a question also about whether Alethio, the block works with Quorum. Does any of our engineers know the answer to that one?
I know that they are planning to support Quorum, but I don't know if it's being done already. But you can definitely use LFTU with other Ethereum clients like Geth or Parity. Since it's using the JSON RPC APIs, you can definitely use it with different nodes. But for Quorum specifically, I don't know if it's ready yet. They are working on it.
Right. And just a correction on what I said on Click earlier, it is implemented and we're running on the test nets currently.
Yeah, we are not using it on this.
We're not using it in the demo.
No, not here. All right. Well, thanks, Sally and Lucas. Okay. So next thing that would be nice to demonstrate is let's look at balances and transactions. And to do this, this is one way to look at the network. This is another way to look at the network. But yet another way is to use a crypto wallet. And this is MetaMask. It's a crypto wallet. It's made by MetaMask, which is another spoke in Consensus. Okay, so if you've set up your account, click the browser plugin, and in this little login box, just log in. All right. Now, personally, I find this UI a little cramped, so I always go to expand view so I can get a full tab. And I'm just going to go through the UI a little bit. This gadget here, even though it's not labeled, if you click it, it will list your account, my accounts that I've created. You can create or import new accounts, connect a hardware wallet, and then further down here, there's a little bit of a UI issue that actually says settings down there, and I can just barely reach it, but I don't think you can see it. And this gadget is the network drop down. So any networks that I can access, I'm going to click on this and connect to them. Now, currently, by default, connected to main Ethereum mainnet. We also have Ropsten, Rinkeby test networks, and we can also connect to a private network, like the one we just started. To do that, go way down to the bottom and click Custom RPC, and it takes you to Settings, and scroll down to New Network. And this is easy because all we need to do is take the same endpoint that we hit for RPC and paste it in New Network. You save it. Okay, it says connecting. Okay. Now, up here, it says private network, and I'm just going to verify that, yes, I am connected to 32777, which is what I wanted. Every so often, there could be a glitch where you see it seems to hang, and there's a spinner here. Just click on that spinner and switch back to main, and then back to private network, and you should be good. Okay, so what we're going to do here is connect to the private network's miner node, and that has its Coinbase account has Ether in it. And when we connect, we'll see how much Ether it's already mined. This is saying we've got 218 blocks, so there's definitely some Ether in there. And we're also going to create a new test account, which will have nothing in it, and we'll do a transfer, and then we can look at that. So first, we're connected. First thing we're going to do is import the miner account, and I'm going to ask Sally or Lucas to paste this number in. This is the mining account private key, or I can do it. I think I have to do it.
Madeline already shared the key.
Did Madeline get? Okay, thank you. Okay, yeah. Very long hex number. That's why you want to copy and paste it. You don't memorize these. And one thing to keep in mind: this is a private key from a demo, and it's in a private network, so we're not dealing with real money here. If it were real, of course, we would not share it. You would never want to share that. Be very careful. All right, let's click import. And there, when the miner account gets imported into MetaMask, MetaMask likes to give it a default name, account 6, but I can change that. And I'm just going to call it, let's call it miner account 6. So we know what it is. And it has 718 Ether, almost $70,000. It's pretty sweet. It's play money, but we know it's doing something. And I've used this, I've run this before. So you see there's some transactions here. In testing, a good thing to do is clear this out. Clear out your transactions and start fresh. So the way to do that is go to settings, and there's a reset account button. So let's just do that. Because those transactions are on a previous run, they're no longer valid, and we don't even need that data. Okay, the other thing is we're going to need a test account to send to. So create account, and let's just call it test account something. 128 is good. There it is. New account, 0 Ether. All right. Let's switch back. Go to my miner account. And we're going to send some Ether. All right. So in this dialog, we have from miner account, and we're going to select the destination, 128. And as you see, it uses these long hex numbers, which are the account ID. And we're going to try sending, let's send 10 Ether. Could be more. And we can select whether we want to slow, fast, or fastest transaction. And of course, fastest costs more, but we'll go with the default. It doesn't really matter on this private network. Click next, and we get a confirmation. We're going to send 10 Ether, and here's our gas fee. Actually, I wanted to, can I edit? Yeah, I can send more Ether, right? By selecting that. Let's do that. Advanced. Yes, there's an advanced tab here. So I don't have to, gas limit was what I wanted to discuss, was the default gas limit. There's a way to estimate gas, and it's the default is 21, but I could give it 40,000. It's how much I'm willing. It's how much I'm willing to pay for that transaction. It's just worth pointing out there. Okay, let's try that. Okay, so here in the transaction list, we see it's pending, and it's waiting for a block to be mined that the transaction will reside in. And it takes a few seconds. We'll see it change to confirm in a few seconds. Confirmed. Once it's confirmed, you can click on that, and we get details on the transaction. There's the from account, the to account, transaction amount, gas limit. We set at 40,000. We're willing to pay 40,000, but it only used 21,000. Gas price, and so if we want to look at this in the browser, there's a trick here. There's a link here. It says view on Etherscan. It's a tiny arrow. And if I click that, it's going to open another browser tab and take me to Etherscan. Now, what that link is actually a link that contains the transaction hash right there. I can copy it from the address. It doesn't have to show up on the page. In fact, the page is just going to be, sorry, we can't find this information. Etherscan can't find it. And the reason is Etherscan reads off the main net, and we're in a private net, and there's no way it can actually tell us anything. But we wanted this number. I copied that, and we go back to our browser, our block browser, and just enter that transaction hash right here on the front page in the search box. And here is a transaction view. It gives us details about that transaction. The hash we entered, the value was 10 Ether. It's in block number 307. The from account to account gas limit used by transaction, gas used. So basically, the same information that we see here in MetaMask can also be viewed in the Block Explorer, which is really nice. And I can click on the block, and I can see information about the block that contains the transaction. As I mentioned before, there it is. It contains one transaction. So there it is. Okay. Of course, as with everything, there's a programmatic way to view this. And we're going to use a method. Oh, and I wanted to say balance. Yes, there's a couple of things we can look at. So back to Postman, let's select get balance, and this will get the balance of an account. Sorry, of an account. So let's give it. Let's give it actually minor account, which is actually it's already got minor account in there, so you don't have to do anything. But I copied it. The way I copied it, just to be clear, is if you go into MetaMask under account details, there's an account number, copy to clipboard. You can always use that. Let's send that. So we requested the balance of the minor account, and it gives us a result in hex, but it's not very readable, right? It's a hex value, it's in way. And what does that mean? So we can open an online tool called Ethereum Unit Converter. It's etherconverter.online. If you can put that in chat, go to that page, go to that site, and we're going to take this value, and we're going to put it in way, and it will convert it to Ether. Now, when we polled, it was 926 Ether. And of course, we're behind 926. It's already on 946. I could do it again. Same thing as with trying to catch up with blocks. See how fast we can do it. 950 now. So yeah, we're actually a little bit ahead of MetaMask, and then MetaMask updated and got ahead of us. So it's MetaMask is polling, and we are polling as well. So that's a useful method to use. I could also go to the test account, which has a little bit of Ether in it. You see, we transferred 10 Ether, and just for demonstration, let's see if we can get the same number. We're expecting 10 Ether, and that's what we have, 10 Ether. All right. Okay, before we break, I want to do one more method, and that is get transaction receipt. So what we do here is we're going to do something with this method. This is a method that takes, if you click body, it will take a transaction hash, this long number, and will give us a receipt for the transaction. It's like the receipt that has detailed information. So it's kind of what we hope to see on Etherscan, except we're going to do it with the RPC. So we go back to our transaction, and we click that. That hash is right here. Let's put it in Postman. And so every transaction is going to have a unique number. Send that. Okay, and now let me copy this out so we can take a little bit better look at it. Okay. What does that look like? We get JSON data back that's somewhat interesting. Okay, so we get similar things that we saw in the Block Explorer. We got the from address, the to address, the transaction hash. Status was good. Gas used. So here's one that we can take this hex number and convert it. Excuse me. I'm sorry. Gaussian way, wasn't it? Yes. So it was, see how I can, 5208 in hex way is 000021 Gwei, and I think that's what we see here. Excuse me. What we're seeing here. Excuse me a minute. Yes, what I was trying to do was bring that back to 21,000 way. But that's what we see, is we see the same kind of numbers coming out of the RPC method as we see in the Explorer and in MetaMask. So let's take a break. Are there questions?
There is one very excellent question. What consensus mechanisms are we planning on using in Pantheon 1.0, and how is IBFT improved? Rob,
yep.
I'm going to point that at you.
Thanks, Sally, and thanks to the person who asked the question. So I guess there's two parts to that. So within the 1.0 release of Pantheon, there will be the consensus mechanisms that will be available will be the standard proof of work, there'll be the clique POA, and there'll be what we're calling IBFT 2.0, which is a variant on top of the IBFT protocol, which follows into that second question of what's going to be different and what are we changing from IBFT. And there's two big things, two main things that are changing. So the first, it's not actually a huge thing, but it's changing the formula for calculating the number of signatures that are required and the number of validations, correct validations that are needed to approve a block going through. And so that formula is used to the formula that's used in IBFT1 is very much optimized around there being a multiple of 3 + 1 validators in the network. And so that would mean 4, 7, 10, that sort of range of validators. If you don't have that number, the formula for checking the number of faulty validators that is available or allowed is sort of it starts to get a bit messy and doesn't work really great. So the updated formula that we've got makes that work much better. And then the other thing is that there experimentally and formally you can show that IBFT1 suffers from some liveness issues, and so it's possible to put the network into a bad state. And so we've got we're taking some techniques from the original PBFT protocol, which IBFT was based on, and bringing those back into the protocol and making sure that it will still continue to work and that the protocol does not have the safety and liveness issues.
Thanks, Rob. There's another question which might also relate to the roadmap, so I might point that one at you as well. Support for off-the-block data and or IPFS, is that on our roadmap?
So that's a beyond 1.1 feature, and we would love to talk to people if that's a feature that they think is really important. So for any features generally, the product team love to talk to people and get a feel for what value we can bring, and how we can most ensure that the client is the client that makes sense for you. So would love to have conversations with people about that. Please reach out either to me, so rob.dawson@consensus.net, or even better, go to support to make sure it doesn't get lost in my email. So that's support@pegasus.tech email address.
Great. Rob? Oh, any more questions? Sally?
That's it for now.
Okay. Rob, we're at we have about 12 minutes left.
Yep. So as Don points out, we're sort of running short on time. What we're going to do, I think, is give everyone a chance to, again, ask questions right now. But we're going to continue into extra time. But wanting to respect people's time as well. And so what we're going to do is, again, just if you've got questions, please drop them in the chat. If you've got questions later, again, that support@pegasus.tech email address. Grace will be reaching out and sending you emails and getting in touch with you afterwards as well. But yeah, we'd love to keep on talking with you, helping you out. That said, we do want to make sure that we deliver on everything that we said we're going to do. So we're going to continue ahead now with the remix part of the tutorial and give you an opportunity to have a look at remix as well. So Don, I'll hand back over to you and let you go ahead and do that.
Cool. All right. Yes, so as Rob said, remix. The next thing we're going to do is demonstrate smart contracts. And what we're going to do is bring up remix, and it's an IDE for writing and running smart contracts, writing and deploying smart contracts, sorry. It runs in the browser, so open a browser tab and go to remix.ethereum.org. And when it comes up on your screen, it's the IDE editor will likely be blank or not. If I had this in here before, so this is, I'm going to share this with everyone. This is Solidity code. It's a very simple smart contract. Hang on one second. I'm just gonna put this in the chat and copy that from the chat. And we'll start with Pragma Solidity 051. And all it does is it has a single parameter value in it that we're going to set. We're going to deploy this contract, and then we're going to set it. A little housekeeping here. Click the Compile tab and make sure that it says Auto Compile, and that'll make sure that it's checking for you. Click the Run tab, and you want the environment to be set to Injected Web 3. And the account should be this account, the miner account, which begins 0xFE3B. You can copy that and you just paste it in here. So Remix, in order to deploy, it uses MetaMask to sign the transaction and then sends it to the client. So if you've done those settings, we should be ready to deploy this contract. Right down here on the right, there's a pink button that says deploy, and let's click that. And as I promised, it invokes MetaMask, and MetaMask is asking us for confirmation. It says, I have a contract deployment with a value of Ether. However, there's a gas fee because it is a transaction. So it's just notifying you. Click confirm. And now you'll see in the output window down on the lower right, it will have information on the transaction that just happened. There's a, hard to say, very small down arrow on the right. If you click that, it will expand all that information and show it in a table format. And it has information that we're going to be able to see in MetaMask. We go over here. Here's our contract deployment. It shows up here. It was also pending and confirmed, and we can open that up and we can see, for example, it has from and then to is null in these cases. In the case of deployment, same thing here, from FE3B. It tells us how much gas was used and other information. We can view here in MetaMask. All right. Okay.
Don,
I'm sorry, I was muted. Let me start that over. I'm not sure how long I was muted, but I was saying...
About 10 seconds, 15 seconds.
Oh, okay. Thank you. What I was saying is that because the contract deployment is a transaction, it has a transaction hash like any other. Click that little gadget in MetaMask. And when it tries to go to Etherscan, just copy it out of the URL. And then we can take that and put it in the block explorer. Go back to the front page, enter it in the search box. And so now we see transaction view on a contract deployment. And it's in block 628. It should have a value of 0 Ether. And here's the gas that we paid. Gas used 113,355 way. And right, if we click the block number, we can view information on the block that contains that transaction. And then back, what else? Back in Remix, we have our table with information about the transaction. We also can look at, excuse me a minute. Okay, so you want to click on the lower right hand. It will have a list of deployed contracts, and click the only one that's there. And what will open up is a set and get button. If we click the green value button, it gets a value, which is 0. And just enter a number in set value. We're going to enter 99. I know these numbers in the UI are very tiny. I apologize for that, but I put in 99, clicked set value. And MetaMask is invoked again and asks us for a confirmation. This one is a contract interaction. So that means that we've sent a value, we've changed a value, we've interacted with the contract. This also has a value of 0 Ether. It's going to invoke a small fee, and it wants us to confirm. So we do that. And now we can go back to MetaMask. And our latest contract interaction was just a second ago was pending. Now it's confirmed. We see details on that as well. We can get its transaction hash and do the same exact thing with that and look at it here. And that's in another block. So finally, what would be nice is could we look at this programmatically? Well, we can. We have an API for that. So I'm going to open the contract deployment that we did. Yes. No, sorry. The same thing that we just had. Make sure that So I am, in fact, making sure that I have the transaction hash of the contract interaction of changing the value from 0 to 99. And what I'm going to do is go back to Postman, and I'm going to go to the last method in the collection, eth get transaction by hash. So what this will do is take the hash, and you see it down here in the method body under params, replace that hash with the new one and send it. And this will also give us transaction information in JSON format. And I'm going to paste it to an editor so we can take a better look at it. And so what is interesting here is I'm looking for the value that we just changed. Where is that? Well, if you look at the input parameter, on the left-hand side of input is a long number, and it's the method signature, and it's padded with zeros, and all the way over on the right, 63 hex, which comes out to, I bet you guessed, comes out to 99, 63 hex, comes out to 99 decimal, and that's the number that so basically this is the place in the JSON package where that value is actually sent. We can trace anything that we can view in the Block Explorer or in MetaMask can also be viewed programmatically. All right. So are there any questions on that?
There are no questions in the chat.
Okay. That is pretty much the end of the demo, and I think we've almost exhausted our hour. Rob, would you like to wrap up?
Sure. Again, just thank you to everyone for coming along and being a part of the demo. We're really excited again to help and show off our product to everyone. We'd love to answer any questions that you might have. Please do reach out to us at support@pegasus.tech, or reply to any of the emails that you're going to receive as a part of this process. Again, it's really exciting with our product, and we look forward to the things that are coming out in the next weeks, months, and years as well. Thank you, everyone, for joining us.